Okay, let's look at the domain and range of these rational functions. So just as a quick reminder, the function when x is in the denominator, if you have the function y equals 1 over x, just as a standard, this is what it's going to look like. So our horizontal asymptote is at 0. And our vertical asymptote would be at x equals 0 also. So to find the domain, we need to know what values x cannot equal. So in this case, to find the asymptote, or what values x cannot equal, we set the denominator equal to 0. Add 3, so x equals positive 3. So that tells us that when this is 3, this equals 0, and that cannot happen. That's going to be a value that x cannot equal positive 3. Now the range, the asymptote occurs typically at 0 in the parent function. Now this one has been translated down 1. So now our horizontal asymptote is at y equals -1. Therefore, y cannot equal -1 because they cannot equal the values of the asymptotes. Okay, moving on to number 5. F of x equals 1 over x minus 6. So the vertical asymptote is going to be where the denominator equals 0, or x equals 0. So that tells us that at x equals 0, this cannot exist. You can't have 1 over 0, so that's going to be a value that will not work. The range, our translation has been moved, or it's been translated down 6. So the asymptote is now at y equals -6, another value we cannot have. So the range cannot include -6. And I'm going to go back to this one and just put all real numbers except for these. So again, it can be all real numbers except for these two values. All right, and this last one here, number 6, we have h of x equals 3 over x plus 1 plus 3. So starting with the vertical asymptote again, x plus 1 equals 0. So x would equal -1. That's where our asymptote occurs, and therefore that is where x cannot have a value, where the asymptote is located. And again, this one has been translated up 3, so our horizontal asymptote has gone from 0 up to 3. So it can be all real numbers, but y cannot equal +3, where the asymptote is located.